This is the basic model, highest selling model of Elementar in CHNS. Okay. So in this one, it has a capacity of analyzing or detecting 14% of 14 mg of absolute carbon. So if your sample, the carbon percentage is 100%, okay, for one end, for like 100%, you can take up to 14 mg of it. Okay, if it is 50% of carbon, so you can multiply it, double. Okay, so your the thing is sulfonamide has 41%.
Correct.
Okay, so you can take up to like 30 mg of it. Okay, so that much you can load in this. Okay, so it has a capacity of loading 80 samples at a time.
Okay,
Okay, so
that's
like you can put, and it doesn't need any human supervision or intervention
okay.
while running the samples. One you are putting and going to auto mode, and it keeps on continuing.
So
Okay.
this is like auto sampler of the once you
Yes,
put
yes,
and
yes,
the
yes.
the instrument does their all these things.
So it always goes on running. So not like that. There are configuration with 240 samples.
Okay, so
Uh,
industry purposes and all
yes,
these
in
things.
pharmaceutical and all that it will be 240,
Yeah, yeah.
and in research purpose and all it will be 120.
20.
Here your sample for soil and all, for carbon identification, it is a tricky part. You have to increase your sample size to get your exact carbon percentage. So what we will do, we will increase the weight of your sample. For example, there is an efficient manner how to find that this one. So for standard, if you are putting 2 mg also,
Correct.
ideally, even if you are putting 1 mg
OMG
also
also it will
or
give
2
correct,
mg also,
correct.
it should give the same
Same result.
percentage
Yeah,
everywhere.
yeah.
Okay, but in the soil sample, you have to find the right spot. Okay, and even the soil is very hard to combust. Okay,
Okay.
so we have an additive for that one also. You can, while preparing a sample, you put little bit of additive. That you have to minus it. Only you have to
Correct. The
load
contribution
the
from the
load the weight of your sample
sample.
only.
Correct.
Then pack it. It depends upon like 1:1 ratio or 1:2 ratio, 1:3 ratio.
Correct.
Like if you are putting 10 mg of your sample, the additive should be 30 mg of it. Okay. So like that you can
30
pack
mg or 30%. मतलब 10
like 10
milligram
mg.
10 mg.
One
Okay.
is to 3 means your
1 is to
sample.
okay.
So
Sample is 1
one,
and the additive is 3
three.
3
Like
times.
1:1 is also more than
Okay,
enough
okay.
for it.
Correct.
Like 20 mg total. But the thing is, we are using this kind of packing materials.
Okay.
This is called as a tin box, where you will these are used for your packing of your samples.
Can you just please open and demonstrate this?
Okay, like this. It will be a like a boat kind of thing. That's why it is called a
Okay.
tin boat. Okay.
Sorry.
Take one more, no problem.
Okay. So this is just like a foil kind of thing, right?
Yes, it is a
Okay.
tin foil. You can say.
Oh, okay.
So there, for convenience, they have given a mold of
Mold
this
of
or
this.
shape of like this.
Okay.
So easily you can put.
Easy can pour.
Uh, and even we have multiple forms of packing material.
Okay.
For liquids, we use capsules.
Okay.
Okay, so
Can you show me one caps?
I'm sorry, I haven't taken it yet. In that it will be very convenient. For cold samples, we have a foil.
Okay.
And for that one, we have a manual pressing tool also.
Okay.
Okay, so you will place the foil in your hand.
Okay.
Okay. Then with the help of pen or something, you will
Something.
make it like a cup
Okay.
by pressing like this. Okay, so
It
and
becomes a cylindrical sort of
yes,
this
sort of
thing.
thing. Then you can tear it first.
Okay.
Then add your sample
Sample.
10 to 15 mg
Okay.
of your like basically that and all in cold and all it is
Correct.
very much used. Okay, so that you can do it. Put it. cover the top of it
Mhm.
like this, and we have a manual pressing tool. It is in there.
Okay.
Put it inside, press like that. It will become a tablet shape. Okay, one side
Understand.
show.
हाँ बोलो.
So there are depending upon your application, the sizes and all increases.
अच्छा.
Okay, this is the foil IC.
Okay. Okay. So different size. Okay.
So the tin we are using in CHNS mode basically, and silver and all we are using at oxygen detection. So that time, so halogens are there, everything.
Correct.
So that time the silver packing material is used. Okay. Why silver or why these kind of this one? Because it's a good conductor of heat. When it falls into this, no,
Okay.
what happens? We are maintaining certain degrees Celsius inside.
Correct.
Okay, so in CHNS it will be 1150 degrees Celsius.
Yeah.
Okay, once it falls there,
Okay.
okay, so for the combustion
Chamber.
combustion part
Demo
of
Okay.
आज ही दे
it goes up to almost
Demo आज ही दे रहा है.
1800 degrees.
Okay.
अगर
So
देखना
in
तो
that,
आके देख लो.
whatever you are putting,
सुदीप दा को भेज दो.
99%
Will
it will
burn.
combust. Full combust.
और
It
तुम
will
भी आ
turn
जाओ.
into gas.
Correct.
Okay. Whatever the gas is done. Okay. So we are flowing the helium every time.
Okay.
So from here it will start. It will go like this and it will go to the
Okay.
column detector and
It will flush out all the
so
materials.
every time it will be flowing.
Right.
Okay.
So
This
helium
gets
is the flushing gas.
Huh.
flushing also, and flushing we cannot say as a flushing gas. We can say it as a carrier gas.
Carrier
Okay.
gas.
It takes along it with
Okay.
the whatever the gas is produced in this combustion. So the output can be anything. Okay, so like basically in this one, the output will be like this: O2, N2, NOx, CO2. Even if you are putting your soil sample also, these are the outputs. If it is any sort of sample, okay. So basically, I think any this one it will be in CHNS only. So no other than that one. Okay, so these will be the output. But our instrument detects on the the gases like CHNS in the form of this N2, CO2, H2O and SO2. But the software is designed in a way such it will give only nitrogen, only
Okay.
carbon. The detection is in the form of this,
In the form of gases.
in this gases, but it will give the exact CHNS percentage. Okay, and we are using multiple consumables inside. This is the combustion tube, as you can see this.
Okay. In
So
this
next
sense.
one is also there. It is covered actually. This is the reduction tube.
Okay.
Combustion. Here your sample comes and falls. Okay, here.
Okay.
So this pipe will give the oxygen for combustion. Okay, so every time the oxygen it won't flow.
Only at the time of combustion,
Combustion
oxidation
depending upon your method.
method.
For 2 mg sample, no need of giving for 150 seconds of
Oxygen flow.
just the 10 seconds
10
is more
seconds
than
is
enough. Okay, so there are calibrated, we can say, methods which comes like in RHO. They have done it and preloaded it.
Okay.
Even if you want a method, you can create it as
Own
per
method.
your
Okay, requirement.
requirement and you can do
Correct.
it. Okay, anything can be customizable. Like if you have any other sort of standards.
जूता खोल के
जूता खोल के उधर से वो देख.
हाँ काल से उधर से आए
अच्छा, ठीक है. Just log it, log it.
जितना है उसका काम चल जाएगा
Any
So-
sort of other kind of
রেকর্ড করে রেখে দিচ্ছি, পেয়ে যাবে সব.
any sort of standards.
ওকে.
Now we are using sulfonamide. Okay. So some other customers who are very much into the carbon detection,
Okay.
like higher 90%.
Correct.
So in like couple of our customers such as Vikram Sarabhai Space Research Center,
Okay.
there, DRDO, ASL, there and all, they will analyze the carbon cloth.
Okay.
So that is used for the covering of the satellite when they send it to space or
Okay.
something to reduce the heat. So that they will analyze. Just a piece they will cut it
Okay,
and
and
they
they
will put
put
it
it.
in that one and they will analyze it. So for that one, this standard is not cheap. Okay. So what they will do, they will, you can add your a separate standard to this one.
Mhm.
That standard is called as biphenyl or diphenyl. It has the carbon percentage of 92% something. Exactly, I don't know. It's above 90. So to get the better result, that standard you can use and you can calibrate the instrument according to that. It will work fine like that. Okay. So now it is calibrated with sulfonamide. Okay. So all four. So coming to this. So in CHNS, these are the four main important things. One is weighing, very much important, and packing. Okay, so if you are not using any microbalance or something, it is very difficult to get precise results. Okay, so and even the packing should be like it should not that thin is there. Na? If you are putting any sharp edge to that one or something, and if you are putting too much pressure, it might burst and that might spill out. Okay, so you never know. You cannot find it.
Okay.
It's a minute particle. You are holding up to 1, 2 mg, 5 mg, something like that. A particle might you cannot see or something. That might you are load. You are taking recording something weight in this one, and you are putting the something weight in this one. There is less. It will give. The result won't match. Okay, so I'll show how to prepare a sample everything with the solids. Okay, and next one is combustion and reduction. Once in these two tubes, it happens the combustion and reduction. Combustion means your sample burns and turns into gas, and the reduction it absorbs the extra oxidants. As I shown it, I'll show again. Okay, so this is the separation. We are separating the gas as like your HPLC, same thing like that. We are separating the components. So same thing. This is the patented one of our element tab. So no one uses this kind of technology in CHNS. Any other competitors, if you are seeing, they will use GC columns in that one. Either than this one. Okay, so I'll explain to what is the speciality of this one. And we are using a TCD detector, same as GC.
No.
So you are familiar with GC, right?
No, no. Please explain.
So even the GC has the same detector, TCD detector. It's a non-specific gas. So it doesn't know what it is getting inside. Okay, so IR is you can program it to specific gas. Like you can program it to either only nitrogen. Okay, so this usually IR we take it in ppm level, a very minute this one. This is in percentage, that's why it's in TCD. And this is I told non-specific gas. So how it works, I'll explain. Okay, these you want explanation? Okay. So these are the packing materials we are using. Okay, so either it can be tin, silver, aluminium and all. So in this we are packing it. Okay, depending upon your application, the sizes may vary.
Mostly soil.
Mostly soil and
And
any plant, everything. Okay. So why it is used means it helps for the combustion and it reaches 1800 degrees when it goes inside this here. Okay. And we are using one more technology called blank free sample introduction. So here you can see this part, no? This part. So even if you don't have this cover also it works fine. Okay. What happens? It has a cup here. You can see here a cup. Okay, so the sample falls here. The sound is getting that. So like that. This is turning here and there, like this. Okay.
Circular motion.
So the sample falls here. It turns to left side, either like 0 degrees. Okay. Here it will flush with the helium. Okay. It will flush with the helium and it drops down to the combustion tube. So that's why it is called as blank free sample.
Please explain once more. On this.
So it has a cup like thing. Okay, the inside it is a cup. Okay, it will be like this. The sample falls like this. And it will turn to 0. Okay. And it will flush. Everything is automatic. Okay, so it flush with the helium. So whatever the particles attached to that or something and all, it goes out. And after flushing, it rolls down to the combustion tube. Then your sample falls down. Okay.
So why this step is needed?
Just for a cleaning or something, anything stuck into that one or something.
It's not for calibration.
So, so this pipe you can see, na? This pipe that is called as O2 lands. Actually, from there your oxygen flows here, and your sample comes and falls here. So this is called as this part called as ash finger, where your residue of your sample packing material, it collects there. Okay, so every 250 samples, you have to take out the furnace with the help of tongs. This is called as tongs. Insert it inside, take out. Okay, and take out. There is a white color thing is there, na? That is aluminium foil. Clean it. Put a fresh one. Place it back. That's it. So, since in CHN, we are using in CHN, the consumables, it changes. Instead of this WO3 granules, means tungsten trioxide granules, we are using copper oxide as a catalyst, okay, which gives the extra oxidation for your combustion. And it flows down. These are the outputs. Okay, O2, N2, NOx, CO2, SO2, SO3, H2O, HCl.
কতক্ষণ পর আসবে?
So these, we want only this. Okay, so N2, CO2, H2O.
চলবে
So it is detected in the form of this.
ঠিক আছে আমি ওদিকে
Okay,
চলে
so
যাবো
we are sending
আমি
this
ওদিকে চলে
direct.
যাবো
আওয়াজ হবে এই জন্য বলছি আমাকে 10 মিনিট পর আসি।
But our in such a way that it will give only nitrogen, carbon, sulfur. It will do some calculations, everything, and it will give. Okay. And here we are using copper. So yesterday sir was there. So we have seen how to fill it. So entire full from here, we have filled till here the entire copper. Okay. So what it does means it whatever here the oxidants are there, it binds with it and it will become copper oxide. Yes. So it will turn black.
so after a certain period of time you have to refill or
Yes.
okay
Like it will last up to like I think so 300 400 samples. This one,
okay
depending upon your this what we can say
samples
oxygen dosing.
Oxygen
If you are
dosing.
putting too much oxygen dosing, then there might
It
be a
will-
chance of getting too much consumed.
the next question is so if it is suppose after a while it will be you have to discard the whole column right means
Not
the packing
one, no,
the packing
inside one.
inside packing right
Inside
so
consumables we are using.
so my question is can we do ourselves or
You
we
can
have to
do
go
it. You can do it.
so is there any extra pack for this one or you have provided or we have to buy an extra pack
like
for this
it
packing
was given for only 1,000 samples currently.
okay
So for next this one, after exceeding that one, you have to procure it.
okay বুঝলে এই জায়গাটা this is a recurring
I'll be
expenditure
very honest. Okay, so Elementa doesn't make money out of selling these.
okay
By selling these consumables only, we make.
okay
So whatever you are using here, you are using silver wool.
It must be cosmetic.
Yeah.
So how much? Suppose in one is this is for 1,000 samples, right? Whatever you have packed. Now, how much cost does it for packing a single column with this?
The cost wise, I am
Around
exact.
around any
Single 5K.
oh 5,000 only.
Like it takes around like 3 bottles of
Okay, this copper.
Like
Okay,
each bottle, I think so, 3,000 something.
each bottle.
Each
Okay,
bottle it comes out like here.
okay. So
So
okay,
it is 100 grams. It will take 300 grams.
300
Three
grams.
is three something around 4.
So this for copper one.
Ah.
How much for this around this silver?
Silver and
wool?
all you have it.
Okay.
It is more than enough. It is there.
Okay.
It will last like for another two fillings. also.
Okay, okay.
These are mostly used. Actually.
Used so
this and
this
all
you
have to pour it up like bottle wise.
After every 1,000.
Yes.
every 1,000 usage.
No, I cannot say exactly. 1,000
I do
samples.
understand. So there is a rough usages of around 100. It's just
Yes,
a bike.
yes, yes.
It's just like
So
bike.
once you
Okay.
start, pull out this. Usually you take out this one, the tubes from the furnace. Whether
Okay.
it is this is consumed means it will turn black.
Black
like
into
this.
copper oxide is black.
Okay, so now it is in copper color. I cannot define the copper color. Also.
Yeah. That is
Okay,
copper
pinkish
color.
something is there.
Okay.
So it will change up to like a black when it oxides. Okay. So, and one thing, if it is consumed half, for example.
Okay.
Okay. For the next time, the next half, if I am filling.
Okay.
You want to change when I am coming for the PM for it.
Okay.
So it is consumed half.
Okay.
The engineer will keep that only, or else what he will do, the whatever consumed part he will take it out,
Okay.
and he will put the fresh this one, and keeping that in whatever the unconsumed one he will keep in the bottom. Next he will fill the fresh one.
Okay.
Like that we will do. Okay.
So and my second
Whenever
question.
you are doing it,
Okay.
in this mode, we are completely filled of copper here.
Mhm.
It is very difficult to take out that outside. Okay.
Okay.
Because when it is in very hot condition,
Melts.
it happens like a block. Okay, so if you are tapping it also, it won't come at one shot. Okay, so you have to do some jugaad or something. Some in other companies they will take a pipe, and in the end what they will do a saw kind of thing, deep saw you can say, like this
Okay.
shape,
Okay.
and they will insert like this, and it will come as a
That is sort of a long spatula, but the head is like seesaw. Small
yes,
seesaw.
Okay, so that you have to do something for that one, and it comes easily. Like if you are touching the
Surface.
edge of the glass or something means you are putting too much pressure, the glass might.
Ah.
Okay. The glass is that tube is costly, and that is costly.
That is because of quartz.
Yes.
That's pure quartz.
Okay, so
2016 it was around quartz tubes this size were around 14,000. Now it's
and now if you are procuring with us, it is like almost
Oh,
like
it is
25 plus.
25 plus.
Okay, so excluding GST, if
So-
you are putting in
So
GST,
less
it will
expensive.
be
This is not
30,000.
then this is not pure quartz. So we have cuvettes.
Okay, so be careful, or else for first 2 times you call the engineer better to see how it's going. Okay. So this principle where it differentiates other competitors from Elementar is here. Okay, this column you can see now. Okay, so this is the column, and it will be here actually. Now it is covered. Okay. This part.
This part, right?
So here it is there. You can come here. Here it is your column. This is your detector.
Okay.
Okay.
So just for
So it has a winding outside that this one column. Okay, so it is U-shaped like this. Okay, so it has a winding above that one, heating coils. Okay, so our column is called as temperature program desorption column. Okay, so it depends upon the temperature what the coils are giving to the column. So what it does, as N2, CO2 and H2O from SO2 are coming out of the reduction tube, directly goes to the column.
Detection.
Okay, so in the room temperature, what it does now, the nitrogen directly flows to the detector without any trap. Okay, the rest of the things will be trapped in the column. We call it as adsorption, not absorb.
Absorption.
Okay, so
Surface.
means surface it will be there.
Sure.
Okay, so what it does once, so that's why it directly flows to the detector. That's why your first peak will be of nitrogen. Okay, then the detector, when the peak of this nitrogen touches the baseline, the detector will send a signal to the column. Nitrogen is finished, increase your temperature. And from 40 for room temperature, from 40 degrees, it will go up to 60 degrees or 65 degrees. Then the carbon releases. Then again follows with the hydrogen, 110 to 130 degrees, and next with the sulfur. Okay, I'm explaining on the CHNS mode only. Now you have currently in CHN. Okay. So just you can see this as it's animate. Okay, so the sample falls, burnt. So all four it is released. The first one will be, and see the graph also. Okay. The temperature of this and the TCD means area. So nitrogen went, you are getting the peak.
It's like fractionation. Fractionation.
Ha. And for the sulfur, we are using this path, okay, the drying tube. Since you don't have the sulfur here, we have kept it empty. Okay. A drying tube, nothing but it will be filled with a color indicator, wet absorber, we can say. Okay, so when it absorbs the wetness of the sulfur, the color also will change. So it indicates you have to change. Okay.
So first is nitrogen, then CO2, then
Hydrogen,
hydrogen,
sulfur.
then sulfur.
Here the
Give a quick-
walls is there.
Yeah, can you just give a quick
So okay, so
explanation?
this is your furnace. Supply. Oxygen supply, and these two are helium. Okay, so one helium line it will be going for the flushing, and one more for the carrier gas. Okay, and here it is going to the directly detector as a reference cell. Okay, so reference gas we are passing to the detector, that one. Okay, so the sample falls here. It is connected through the bridge called quartz bridge. This one downside. Okay, and this is the combustion tube, reduction tube, and it goes to the column. I explained what is the use of column. Then it flows directly, nitrogen, hydrogen, carbon. It flows directly to the detector like this, and the sulfur it changes the walls and it flows to this drying tube and it goes to the detector. That's it. It is required for us. Any leak is there, we'll find it. It will be very easy.
31, 32, like these numbers.
That is the number of this tubing. It has some, you can see here tubing numbers will be there. You have in the stomach. Okay, so that time it was used. Okay, so one thing here instead of 120 you are using 80. Means soil samples and all, the packing might be bigger. That's why a bigger space is given. Okay. So if it is 120 means that hole will be smaller. Okay.
But you said 250 samples.
No. That's not the number of
That for
samples.
not for the soil, right?
Like like in other companies they are not using. It depends upon your configuration of that. Okay, easy, reliable, is very easy to work with the software actually, single page software. There is no like any other where you have to go for searching that this and all. In the single screen you can find everything there. Okay. That's it. Hope you will give some more other instruments to buy like steel.
Any other person?
Igor is different company, right? This is there, na? This clamps if you are not putting properly or something. The helium flow will be exceeding. Okay, so that at that time it gives an indication if it is flowing exceeding. So put it properly, make it one more time connection. It is fine. It will be arrested.
So the connection will be opened now after this completion. So again reinstallation, the
Reinstallation, nothing is there. That too, this one is there, na? Regulators. That you take it out, fit it to that.
And the pressure you are controlling, right?
For the helium it is 1.2 to 1.25.
1.2.
1.2 to 1.25. Okay, bar.
So that's the outlet flow.
Yes.
This is the PSI. We have to again.
Nice.
There are two skills as well, I think.
So that only you can keep it this one into the 1.21.
Okay, the trade one.
Yeah. Okay.
That is kg per centimeter square.
Yeah. Okay. So we'll measure like we'll say it as a bar. Okay. So this one done. And this one 2
This one?
2 2 2
Two.
2 2.
Two, only two. Only two. Achha. This part. Let me understand what these units are and could you explain?
Okay. So this.
ये थोड़ा हटा दीजिए.
I'll show the screens actually. This is the
वो
sample.
थोड़ा सेफ जगह में रख लीजिए. ठीक है ना?
Sample screen. This one.
Okay.
This is the graphic screen.
Mhm.
Means graphs will indicate.
Good.
And this is the instrument status.
Okay.
Okay. So and this is the menu bar. Okay. This is the title bar. Okay. So in this one here you can see where with respect to the samples you are seeing the view actually. So here you are putting the weight of your sample, name of your sample.
Correct.
It can be anything. Okay. For your identification.
Okay, we have to put the weight of the material.
Yes. Yes.
Weight can be anything or it should be
अरे,
one.
limit है ना उसमें?
limit.
Yeah,
limit
what's
है.
the limit?
Limit like if you are putting a soil sample or something,
And this is the
take
way
it
machine.
maximum 5 to 10 mg. It is more
5
than
to
enough.
10.
बहुत ज़्यादा है. 5 to 10 mg for CHN.
This is the way machine.
हाँ.
Here
this
is
is a
1
balance.
mg, so should we take only 1 mg?
So for see
वो
for
by default value है.
नहीं
आप
नहीं
उसको
नहीं
change कर सकती है.
नहीं ये है ना ये blank के लिए डालते हैं.
Okay.
Okay.
Okay, okay.
So or else it doesn't take if it is 0. Okay, so something should be a number. Or in previous and all, they used to put like 000 point, point 001 like that.
Okay.
So just for our this one.
Reference.
Okay, so it has to
So
start.
if I want to put another number like 2,
Why you will put it?
like
So what is the reason
for
why you are
example.
putting for a blank as a 2?
With the respect, it will, if you keep it 1 with that respect.
No.
then-
What you want to try to prove if you are putting 2?
No, just ask if we change,
Like
if we want to change.
accident, it doesn't affect. Why you want to put 2? I am asking.
No,
Your
just
sample,
for
our
an
sample
example.
weight is also 2.
See,
And
see,
If the weight
not
comes-
like that.
if the
Not
weight
like that.
comes-
The sample you are taking and you are weighing it. It is giving some X weight. Okay, that you will insert. Simply without of no reason why you will put 2.
Okay.
Okay, you can put 2. I am not saying you can put 2. It gives the same results for blank whatever you put. Something number should be there in that one. I am saying.
So it's not necessary that the blank weight and the sample weight should be same.
No, this is for this one. The instrument will, if it is 0, na, it will throws an error like sample weight is 0.
ওটা internal calibration at value দেওয়া আছে বুঝতে পেরেছেন
Okay.
that is what they are saying.
যদি কেউ চায় ম্যানিপুলেট করতে
So,
ডেটা
so,
কনভার্টার
so you cannot. I think yeah, that will show some error. If you do want to manipulate, just take the CSV file and do it in origin. That will give you better manipulation.
क्या मैनिपुलेट करना है?
क्यों?
पहले किसी को अगर नहीं वो बोला कोई अगर मैनिपुलेट करना चाहे राइट
हाँ.
इफ ही हैज अ बैड इंटेंशन
हाँ.
सो वहाँ पे अगर 2 पुट कर दे
हाँ.
सो इट विल टेक सम मैनिपुलेशन.
नहीं ऐसा नहीं होता. ब्लैंक के लिए make it a uniform manner. You can put 2, you
Actor
can
is
put
with
10. It depends upon your comfortability. I'm saying why for blank you want to put 2. I'm asking that. What you want to prove? Okay. So the basic what we will follow is putting 1. Okay. To start an analysis, in that I was in this one. You can put multiple names also in that one. For your example, you have a soil sample. You want for the identification purpose. This is for this one. This is for this one. This is for this one. For that one, A1, A2, X1, anything.
soil form here,
You know the name of the sample. That all you can put. Okay, so
soil form जो हुआ
black soil 2, like that. Okay, depending upon your convenience, you can put the name of your sample. But the method is there, na? You can create a own method of yourself. If you have like for that one, you have to do multiple R&D, everything. Okay, so there are multiple methods here. Okay, I'll just show it. So here you can see it is now it is running. Na, you cannot highlight it. 2 mg, 5 mg, blank with O2, blank without O2, graphite, plant, soil, everything. Okay. You can use this also. It is like it depends upon this one O2 dosing. Okay. Here also it will be same on the 5 mg for 90 seconds.
So
Any
my
method can be.
my
Like-
second question is if you are dosing the sample with 90 seconds right for O2. So is it the standard protocol you follow for every sample? So how do you judge that you have to dose a particular sample with certain time period? Like here the sample here the dosing time is given 90 seconds. Suppose if I dose it more or less, will that my sample dependent or
It depends upon your sample also.
so
How it does for easily combusting this
Combusting.
one. It not required 70 seconds or 90 seconds.
seconds
Also.
dosing?
It does require or else in that temperature something and all it will burn like anything. Okay, so for soil and all better you keep 90 seconds of
तेरे देना
dosing.
2 minutes धरो तो
90 seconds of dosing. Okay, so we have I showed na we have like 5 mg standard that you can use it.
So any method can be used.
Any method you cannot use it. Like 2 mg is like you can see. Okay,
auto dosing
70. Especially you are using soil means
true
go with the
5 mg.
5 mg standard. It is good.
It's soil.
Soil also it will be same only 90 seconds.
Okay.
Okay.
Like if I'm using a soil sample, should I use the method soil?
You can use it. You can.
How can we choose what sample is responsible for what standard?
No, it's not standard. It is a name given for the method as 5 mg standard. That's it. Okay. It's a name.
And
So you
how
can. There is a drop down. You can
So
come
for
here.
soil, 5 mg is standard. 5 mg standard is.
Is sufficient. That is sufficient.
Sure. Can I if I just touch here, how can I write this?
Double click it.
Okay.
Insert whatever you want. Press enter.
Soil?
Easy.
Soil blank. इस पे थोड़ी गड़बड़।
हाँ वही मैंने पढ़ा था कोई एमपी में कुछ जगह का नाम है
And these three color,
That I'll come. And this.
which one is nitrogen? Which one?
This one, sample. In
Yeah.
this one, you can. It will show the areas
C
of
area.
it and the percentage of it. Okay, and the ratio of CN, CH ratio.
Area means total volume.
Area. Whatever you are getting in UV spectrophotometer, same thing.
Yeah.
Okay, how much it is spread across
And these
from
are the
this point
these are
to
the
this point.
percentages of those
From this
gases.
point to this point, how much it is there. Okay.
From where to where?
From this X point to this
Okay.
cross mark. This is the starting point and this is the ending point. Okay.
Mainly, I would be using C to N ratio.
That you can take it. Here it is. It will automatically comes. In blank it won't come. Okay.
C to N.
Okay.
So blank, we are not putting anything.
Nothing. You are not supposed to put anything in blank. Here you can see C2NH. You are said.
C to N.
C to N. Okay. Like this. So it gives it. Okay. And there is some other also. A factor, a blank. So this blanks values and all. This blank, if it is too much high, if it is less than 500, if you are getting an area of 10-15,000 and all, 500 doesn't matter. So the blank should be less than 500 as per our recommendation. That you want to achieve means you have to get a high purity silicon. Both. Okay, I don't know who is the high purity supplier for here, but in our place it will be a Baruka cylinder. I am pretty sure like you will get it in below 100. Okay, so these blanks and all, whatever you are getting in this blanks, it will be below 100. Like this zero it will come. Nitrogen.
But here the values are more than 0.
Now here you can see 1,000, 800. It is not that much pure. Once it is getting 10,000, here 4,000. Before that it is 8,1. Can't rely on it, na?
So it's not.
So above 500 it's not reliable.
1,000 it can be accepted.
Acceptable.
Okay, so we'll prefer to be below 1,000.
Below 1,000.
Below 1000.
If it is not at all coming, means you can minus that blank value with the sample. Okay, that you can minus it. We have a column for that also. Okay, and you have a moisture this one, that also you can get it here. Okay. Moisture percentage. If you know the moisture percentage, you can put it and you can get the corresponding result as per that.
And for that, we need to have a fresh weight and a dry weight.
No, not like that. I don't know how they will calculate the moisture percentage in that. No? I think there will be different steps to follow to find out the moisture from an element. I don't know, but still it is there. Okay.
So you can enter the moisture percentage.
Yes, it will give the exact. And this is the graphical representation of your area. this can be customized as per your this one. Okay. Now I have selected, as I shown, this is ADS column, the column temperature. Okay. For example, I'll take this. The column temperature, as I told, for nitrogen it will be in room temperature. For carbon it increases. For nitrogen it increases. The same thing. Whether it is increasing or not, for my confirmation, I have enabled it. That's it. Okay. If you don't want that one, you can take out that. And this is the O2 dosing. So